Thank you very much. So yeah, let's get started. Very briefly about me. Yeah, I've been in the industry for a while, and I run my own company for solo projects such as Reconfigure and for freelancing work. And I'm one of the co-founders of Legend of Grimrock. And here's some titles I've worked on. Probably some of them at least are familiar to you. And this talk is centered about Reconfigure, and as mentioned, and it's a game that I've been working for about a year now alongside my freelancing work. And it has like this visual style which combines retro kind of graphics, very old school, gritty, pixelated look, but under the hood it uses like a bunch of modern rendering techniques. So in this talk I'm gonna cover that why in the first place did I choose this approach, and then what kinds of techniques, tools and workflow I use to accomplish this style. And then very briefly I'm also gonna touch on the limits and challenges that are inherent to this kind of style. So as an overview, you know, a lot of, just to cover the basis, like a lot of like AAA, very ambitious projects, they tend to use very high fidelity, super detailed, super realistic graphics. And yeah, obviously, these kinds of games look great, and it's easy to sell these kinds of games to consumers. But you know, the competition is tough, you know, the bar is always rising, and you need more and more work to pull off this kind of approach in a convincing manner. And it's very expensive to create all the 3D assets and textures and other things required for it. And it's just darn difficult as well. You need a lot of technical know-how and expertise. And on the other end of the spectrum, you have very retro-leaning graphics, as demonstrated here by Caltic. And and a lot of indies tend to use these kinds of styles because creating content for these kinds of games is very cheap. But thanks to these factors, the market is also like packed full of games that use retro style visuals, and so it's become pretty difficult to stand out within the competition. So what I have chosen to do is combine these approaches, where I have a thing that is superficially very retro looking thing, but it's powered by modern rendering techniques. So why I choose to do this approach? Well, here's a handful of reasons. My favorite one is up top. You know, you can make the style look exceptionally good, but it's still very easy to build. You know, I'm doing this project solo, and I intend to do quite a bit of content for it. But you know, it sits at this perfect intersection point where you can actually build a quite ambitious game all by yourself. And this is still relatively unexplored territory as well. There are less developers out there competing with similar styles, at least for the time being. You know, I'm certainly not the first to do this kind of stuff, but still, you know, compared to like retro styles, there's way less competition. And one convenient thing about doing modern rendering with a low resolution and heavy post-processing is that actually a lot of the tricks that are intended for very high definition games, they are more practical, more easy to use, more easy to implement when you have a low resolution and a limited palette of colors. Artifacts are hidden by low resolution and dithering, and you can tone down the quality of a lot of your settings, so performance is much less of an issue. So you don't have to spend as much time fine-tuning your rendering systems or your content or optimizing either of those. And in the development side, this is indeed a very practical approach. You have very clear limitations. As an artist, I'm firmly in the camp that limitations feed creativity. It's helpful to have some boundaries and then paint within those boundaries. And my game in particular, it actually has a hard limit on the detail. The most detailed thing that I can put in my game is 3.125 centimeters pixel. That's my texel size in the game world, and I'm not going to do anything more detailed than that in the game. So that helps me from zooming in infinitely to some minute detail. It helps me paint with a broader brush. And developing the game is quite rapid, when you have low definition content in it. All the meshes and textures in the game, they are obviously quite easy to do, when you have low polygon models and a limited palette for low resolution textures as well. But also like implementing all the rendering features and leaning on with readily available assets and shaders. That also helps speeding up the technical development of the game. And when it comes to like a lot of add-ons and shaders, many of those don't really mesh in really well with like purely retro-styled games, because they are intended for a different purpose. And then on the other end of the spectrum, if you are making an actually like a bleeding edge hyper-realistic game, the readily available add-ons and shaders probably are not enough for you. So, this kind of style is very suitable for utilizing work that other people have done for you for free. So, this is like probably the most powerful aspect of using a very low definition image, a very grainy image, is that all of us are equipped with a brain that has been like wired to fix missing data. When we look at this painting by Claude Monet, it's only a couple of brushstrokes, and I can tell that there's people on this boat. Even this and that boat, they are clearly legible as boats with people on those boats, despite the fact that on the boats on the background, the people they are literally just a single dab from a paintbrush. We turn noise into signal effortlessly, and it doesn't cost any CPU or GPU computing power. So now we have roughly covered that, why I personally think that this is a good idea in principle. So let's take a closer look on how I've done it in practice myself. Let's start off with the bigger stuff first, post-processing and lighting. So dithering, my game has a very obvious dithered look to it, and dithering is an old technique. Old school computers, they only had like a limited palette of colors that they could display at any given time, so they used this way to optically blend new tones of color by putting different colored pixels next to each other, and yeah, the idea itself is nothing new, like this pointillist painting by Georges Seurat here demonstrates. It's more than it's like 250 years old painting by now. And yeah, for my game I use Godot Color Dither by Donitz, which is available on GitHub, and it uses a Bayer threshold matrix for dithering, which produces this kind of like checkerboard looking effect when it dithers the image. And here you can see what the game looks like in a high resolution without dithering. And this is the game with the post-processing on and with a lower resolution. So I myself, when I implemented this shader in my project, I went with a relatively high count of colors. I have 16 colors. And when playing around with the shaders, I quickly discovered that the Bayer matrix that it uses a 4x4 matrix, which looks great on like when you have few colors across a broader surface. A larger matrix, a larger blending matrix looks better. But I discovered that, since I have quite a lot of colors involved in the dithering process, and the details on screen, the surfaces on screen, it's still like fairly tight and small in scale. So I went with the smaller 2x2 dithering matrix, since it displays details better when you have a lot of colors involved with your palette. And with a larger matrix, I ended up with a lot of like messy, weird looking pixels that are smeared around the place. But when there's like a smaller surface area that the dithering algorithm tries to cover, it helps to keep those in check. But you can play around with different matrix sizes. You need to modify the shaders yourself, but it's not complicated to implement a different sized matrix within those shaders. And I actually cheat. The final image that is rendered on the screen, it's actually not paletted. It's a full color image that is on the screen. And I blend together the dithered image with the original full color image. So I have a 60-40 blend. So 60% of the color comes from the dithered image and 40% comes from the original image. And I've discovered that it's still for the viewer, it still looks totally like a dithered old school image, even though there are like a lot of shades within those pixels. But for the viewer, it still looks like an old school game. And this blending of having a bit less of the dithering effect it helps with like the image being more stable. If we look at this previous slide where we have dithering at 100%, the image appears fairly coarse, partially due to the kind of big palette that I use. But having a little bit of like full color information blended in, it helps especially with like smooth camera movements or changes in lighting, where the pixels actually there's like a bit more gradual changes happening within those pixels. It's not an on-off switch from one color to the other. Instead there's a bit of a smoother change happening over time. So, always cheat if it improves results. Applies to other fields as well. And for lighting, it's fairly simple for me in a technical sense, because I mostly just use Godot features. I only use real-time lighting. I haven't felt the need to do any baked lighting so far, and it's good if I can avoid that hassle. It involves a lot of kind of boring stuff and maintenance that you have to do. If you can run it real time, that's always great. So, I just enable a bunch of rendering features. You know, if I see a checkbox in like the post-processing settings, I enable it. So I have signed distance field global illumination and screen space indirect lighting, screen space ambient occlusion, screen space reflection, and glow. So a lot of very cumbersome abbreviations. And yeah, the convenient thing about like having a very stylized and also a very low resolution grainy image, that you can actually push these effects further than they are originally intended to be used, or what would be possible physically. Like I certainly have like a way more bouncy light in my game than is possible in reality, but you know, within these stylized kind of looks, you know, it turns into a part of the game's visual style without looking out of place, even though it's like kind of unnatural if you know what you are looking at. And low resolution and the heavy post-processing, it hides a lot of artifacts, rendering artifacts. You can turn down the settings of many of the effects quite a bit, and shadow maps look crisp even with like medium resolutions. So, you know, there's a lot of convenience there, and that puts less pressure for you to optimize the game. So all of these things for a game like this, they are very quick to implement, because you can once again paint with very broad brush strokes. You know, you can turn on a feature and spend 5 minutes fiddling with the sliders and you're all set. You know, you don't have to go through your content with a very fine-tooth comb to kind of like discover all weird issues and edge cases, because you know your game is gonna look grainy and low resolution, so there's no need to pay too much attention to details. So that all of that enables you to move very quickly forward. And yeah, I also use fog, very heavy fog in the game, and it's not only for flavor and mood, because in a low resolution game, when you look way into the distance, there's like a lot of very small, minute details, and you know, if you turn the camera around or move around in the space, it's gonna alias very heavily. So hiding things beyond like 20 meters or so in my game's case, that helps reduce this very disturbing looking aliasing. And in a low resolution setting, aliasing is can be a pretty big problem, because you know all the aliasing artifacts, they are quite sizable on the screen. You know, they're not like these pinpoint-sized pixels, but you know, they're like these fist-sized blocks of color on your face. But yeah, of course, in my game's case, the fog or the darkness, that's also like a part of the visual style as well. It takes place in this like very dark, brooding, ominous, atmospheric spaceship. And yeah, one luxury that's affordable in low resolutions is super sampling. You know, instead of anti-aliasing, I just use a 2 times super sampling over the whole image. So the game renders essentially in double resolution, and then the final image is kind of like shrunk down. So all of the pixels that you see on the screen, they are sampled from 4 pixels. And like I mentioned previously, aliasing can be a pretty big issue here, and anti-aliasing techniques, they only usually take into account like the edges of meshes, but super sampling, naturally it applies it over the whole image. So if you have hard edges on your textures or whatever, like I do, since I use nearest neighbor sampling for all the textures, so super sampling smooths those out. And once again, you know, if you do small camera movements or things are moving slowly on your screen, you will avoid a lot of nasty looking aliasing in your image this way. And yeah, I'd like if this slider went further than 2.0 multiplier, but I don't know if there's like some technical issue that prevents it going further. I haven't looked into it too much, but I wouldn't mind having like 4x4 pixels because then I would only have, you know, the equivalent of a 1080p image roughly to render. And yeah, I also use motion blur, and once again, very conveniently, if I tone down the settings of the motion blur, it works for my favor. You know, my game is very grainy, and you know, if the motion blur is grainy, the artifacts actually contribute towards the game looking good. As opposed to if you have like a realistic game, you want the motion blur to be kind of buttery smooth, very filmic, realistic kind of motion blur. But you know, I can stylize my game by optimizing it. That's great for me. And yeah, I use this Sphinx Owner's Godot motion blur toolkit that you can find on GitHub as well. And yeah, quickly about how I create content for my game, because it's not only about the technical stuff. It's this also has like a lot of advantages to what it comes to like actually creating the assets, the meshes and textures for the game as well. For all the materials and textures in the game, I use the same palette as I use for the dithering, and the dithering works better, especially with the blending with the original full color image. It works better if all the content matches with its palette to the dithering post-processing effect. You know, all the lights, all the textures, all the particles, they use this same palette. And I use physically based rendering materials in the game, and once again, conveniently, I don't have to be like very precise in how I use those materials as well. You know, I can just roughly tune in the roughness values without paying too much attention that am I actually correctly representing this material virtually, because you know, once again, the heavy post-processing, it hides all nuance, so you just need to hit the correct ballpark, so you can very rapidly tune in all the parameters of your materials. And yeah, I also use displacement with contact refinement parallax mapping with low-res textures. Here's an example of, well, one of those. Well, this is kind of like this dimpled looking wall, and over there I have my texture channels. There's color, depth, and a normal map that has been just derived from the hand-painted depth map. And yeah, I find that this combination of using displacement with low-res textures, it's quite striking, and it looks quite natural, at least to my eyes, and it looks great as well, despite the fact that, you know, this is something that is definitely not possible with like old school hardware. I use sprite for my textures. I have a small custom additions I've made to it, some small scripts, and basically the workflow that I use is that the different PBR textures are all contained within the same document, and they are here in the document as animation frames. So I have color over here, depth, emissive, and normal in this textures case, and the normal map is generated from the depth map using an extension for sprite. And I have a script that goes through all of these frames and exports all of those frames as PNGs. So this file is called science equipment. So the color is called science-equipment.png, and then the depth channel gets its name from the tag here. So the depth channel is named science-equipment_d.png and so forth. So I can very quickly update all my different textures that a PBR material with displacement needs. And all the game's content, the stuff you see in the levels, everything is a box. Everything is a textured box. And most of the environment materials, they are just tiling textures. And I model these levels in Godot editor with a custom tool that generates these boxes. And yeah, they are. I did a custom tool for that because external tools they were for such simple content they were just too cumbersome. I tested like half a dozen different approaches, and I ended up writing a box generator with keyboard shortcuts for Godot because it's just rapid and convenient to do it that way. Let's see if I can get the editor over here. I need to go and set up on this side so I see what I'm doing. I'm just very quickly going to. So yeah, here we have a box. Let's duplicate it. Over there on the bottom left-hand corner, I have controls for the granularity of my operations, so I can resize the boxes using just keyboard, and I can modify the UVs as well. So all of this stuff over here, yeah, all of them they are just boxes. And let's go back to the presentation. So yeah, this is very rapid way of creating the levels, and I don't need to maintain external assets or handle exporting, importing, or whatever. It's all very straightforward, and all the text cells within the game, they stay at even sizes because the box generator tool knows the texture it is assigned with. The material contains. It reads from the texture that how big is it, so it resizes its UVs so that all the text cells you see within the game world are 3.125 centimeters across. That's, I think, 32 pixels per meter. And for the more finely detailed assets like props and items and enemies, I use Sprite Mesh 3D, which produces these extruded 3D meshes based on their alphas. And it supports animations, so I can get simple sprite animations with a 3D look as well. And yeah, here's an example of how I've used the Sprite Mesh 3D to build these kinds of blocky science equipment from these pieces over there. And you can also see some animated frames over there where the text or the displays have animations embedded within them, and the Sprite Mesh 3D just animates across UV space. So that's roughly it for like how I build the game, very roughly, very high level, kind of like sweep over the whole thing. And obviously this, for balance's sake, I also have to acknowledge the challenges and limitations. You know, nothing is perfect. Everything is a compromise of some sorts. And over here, you know, the limited palette, it also helps you create stuff, but it's also like a bit limiting. For instance, I have like very few tones in my palette for yellows and greens. So if I make like large surfaces using those colors, they won't be shaded very neatly. Whereas if I have like a gray wall or a blue wall, it's gonna shade much more neatly, since I just have more tones in my palette where the shading can pull colors from. So yeah, with yellows and greens, I only use them for like small accents and particle effects and things that are generally smaller on the screen. And yeah, resolution obviously limits the viewing distance within the game. You know, when you look at things very far away, they turn very small, and it doesn't take a lot of distance to turn something into the size of a single pixel, and then it becomes a rendering issue. So viewing distance is limited, level of detail must be kept low, but I don't mind those limitations. In my mind, there are advantages, but you know, if you were to apply these ideas elsewhere, it might be different. And legibility of text can be challenging, especially if you have some texts within Word that are fairly small in scale. It will be, or it can be, quite difficult to read, and especially if you want to support localization with like very complicated glyphs, then the issue gets even more difficult. So yeah, for summary, yeah, make practical choices. You know, as an indie developer, it's a good idea to aim for something that makes the game look great and makes it easy for you to develop the game and actually finish the game at some point. And yeah, if you explore some visual style where you have less competition, that will naturally mean as well that you're gonna stand out more. You know, if you operate in a less competed field, it's easier to stand out, and it's easier for the people who are exposed to your game. It's easier for them to remember your game as well. So that's it for this presentation. Now I think I am ready for some questions. Thank you.
Can you hear me? Awesome. Yes, we have 15 minutes for Q&As actually.
Hi. One thing I didn't see is how do you decide on the FUV or like field of view setting? Is it just like a subjective style thing, or do you have a specific setting you recommend for this kind of game?
I don't have a specific setting, and I've varied it a little bit throughout the development, and I'm not sure what's gonna be the default setting for my case, but I don't see there being like, you know, any issues with preventing the user from modifying the FOV either. So I think I'm gonna at some point add a slider in my settings for that.
I have two hopefully smaller questions. First one is, you wrote your own box generator script.
Yeah.
There is the CSG tool node in Godot. They say you shouldn't use it for production, but I guess for what you are doing, it could be worth it. Yeah,
I looked into it very briefly, and you know, very high up in the documentation, it says that, you know, we don't recommend this for production use. And I'm not exactly sure what the reasons there are, but you know, when I looked into it, at least out of the box, it didn't do UVs the way I wanted to do them. So, you know, I just went that, okay, it's just a box is 6 polygons, how hard can it be? So I did it by myself.
Hi, what's your stance on giving the player the option to customize your post-processing options?
Yep.
And I'm going at this from 2 different angles. One is like the intuition that you've got an artistic vision that you want to see realized, but I found that with my shaders, a significant portion of players didn't really like them, even though I like them a lot and prefer to turn them off. And the other thing is you wrote that everything's cheap at low resolutions, but some of the post-processing options that you listed seem to be quite expensive, and so there's also the intention to broaden the amount of players that can play your game with lower hardware.
Yeah. I'm definitely going to add settings for the post-processing effects, and you know, the people playing the game can turn off the displacement and all the fancy effects. The game still works visually quite well, even with all of those settings turned off. When it comes to like artistic vision with regards to like very heavy post-processing, I'm probably going to expose a slider for adjusting the amount of dithering. Like it kind of hurts me personally, you know, in an artistic sense, but I also realize that, you know, that's just the smart thing to do. You know, if someone is turned off because of the dithering, they can, you know, turn the slider down. However, the low resolution isn't going anywhere. You know, that's so baked into how I built the game. So it's gonna be, you know, 270 pixels vertically, no matter what. You know, I build all the UI and such with that limitation in mind, just for the convenience's sake. But you know, if there's a massive uproar, I might add like a 2x high definition mode. But you know, that's just gonna be like an optional, non-recommended way of playing the game.
So you mentioned that you generate your normal maps from your depth maps.
Yeah.
And then you author depth maps in A-Sprite specifically.
Yeah.
Is there any situations in which you have to then sort of customize your normal map, or go back in there and fix like misgenerated artifacts or anything like that? I noticed that in the example you provided, the depth map had a very smooth curvature to it.
Yeah.
But the normal map was a hard cutoff in the middle.
That hard cutoff in the middle, that's actually just, you know, an optical thing. It was 2 linear gradients meeting like this. It wasn't like curved gradients. So actually what happened in that example's case, you know, it was just hard to perceive what is going on. And sometimes working with depth maps, it kind of plays tricks on your mind. You know, you think you are seeing things and you think you know the depth map you are making, but you actually constantly have to be monitoring your results in game as well, because you know you can't, or at least I can't, trust my eyes really when it comes to painting the depth map. You know, you slowly develop better instincts for it, but you kinda always need to monitor the results as well, because it's a bit tricky, but you know, with a few pixels, you know, very low resolution textures, it's completely manageable. I wouldn't use that approach with like higher resolution textures probably. And I forgot, did you have some level in your question that I forgot to cover? Was there more? Great.
Hello. Thank you for giving us a tour of your visuals. I was wondering, do you do channel packing, or you decided it's not worth it at this resolution in iSprite?
I don't do channel packing, at least for the time being, and well, we'll see. I have the option to do so, but for the time being, everything's just like super straightforward. You know, I avoid doing fancy tricks until I need to do them. So you know, everything's quite, you know, I just do things out of the box, and you know, if I feel the need to do something, or if the need arises due to optimization's sake, then sure, I'll consider doing things the more fancy way.
You said that text legibility is a problem. What about the user interface or like the heads-up display? Do you treat that differently? You could render it at a different resolution?
Yeah, I could render it in a different resolution. For the time being, I'm keeping like the output resolution the same as the game's resolution basically is. I mean, obviously, it's of course scaled to the viewport size, window size, or display size used, but still, you know, what Godot outputs, or that's still 270 pixels across. It would help with legibility to have like an option, perhaps for higher resolution fonts, and I might consider doing it at some point, but as a baseline for my game, you know, kind of like the sort of the ideal version of the game, in my mind, it's this low resolution viewport where all the pixels align and nothing breaks off the grid. But yeah, for accessibility's sake, I have considered, but I haven't done anything about it yet, that I might render some UI things at a higher resolution if the user enables a checkbox in the settings.
Any more questions? All right, awesome. Then thank you again so much, Antti, for this talk. The next one coming up in about 15 minutes will be plants, polygons, and pixels, large-scale vegetation rendering in Godot. And again, a massive thanks to Antti for this talk. Let's give him another massive round of applause. Yep.